So today we are going to look at the basic electrical quantities. So here we have altogether 5 basic electrical quantities. But now for the moment we are going to look at the first basic electrical quantity, which is charge, and as well as the second one, which is current. But I wrote all this together because current is dependent on charge. Now, we denote charge by the letter Q and we denote current by the letter capital I. The SI unit of charge is Coulomb, and we write down Coulomb in capital C. It is a symbol of Coulomb. And the SI unit of current is Ampere, and the symbol of Ampere is capital A. Now, what is current and how current is related with charge? Now, the definition of current is defined as the rate of flow of charge. So current is not only the flow of charge, but it is the rate of flow of charge. Now, what is rate? Rate means per second. So current represents how much charge is flowing in 1 second. So the equation of current is I is equal to Q over T. That means how much charge Q is flowing in per second will give us the value of current I. Now, I is equals to Q over T. So, we know from above that the SI unit of charge is Coulomb, and we know from before that the SI unit of time is second. So, the unit of current is Coulomb per second. So, Coulomb per second is equivalent to Ampere. As previously I told that the SI unit of current is Ampere. And from this equation we have seen that the base quantity of I is also Coulomb per second. So we can say that Coulomb per second is equivalent to Ampere. Now what is 1 ampere? 1 ampere current flows through a circuit when 1 Coulomb of charge passes through the circuit in 1 second. Similarly, 2 ampere current represents that 2 Coulomb of charge is flowing through the circuit in 1 second. Now, the question is, how many electrons will form a charge of 1 Coulomb? So, how many electrons are there in 1 Coulomb of charge? We know that the charge of 1 electron is 1.602 into 10 to the power minus 19 coulombs. So, using unitary method, we can find out what will be the number of electrons for 1 Coulomb of charge. For example, 1.602 into 10 to the power minus 19 Coulomb is the charge of 1 electron. Therefore, 1 Coulomb will be the charge of 1 over 1.602 into 10 to the power minus 19 electrons. So, using a calculator, we find out that it represents 6.24 into 10 to the power 18 electrons. That means in 1 Coulomb of charge, there are 6.24 into 10 to the power 18 electrons. So, when 1 ampere current is flowing through a circuit, this means that in 1 second, 6.24 into 10 to the power 18 electrons will be seen flowing through the circuit.